Okay. Hello everyone, very good morning. I welcome you all at India's most comprehensive preparation platform for all competitive exams, that is BYJU'S exam prep. So guys, this is another video in the monsoon series session. We are discussing discrete mathematics. Yesterday, we have discussed the concept or the basic concept related to propositional logic. Today, we will understand this concept of rules of inference. Sorry guys. Okay. So, please bear in mind, for ECE, this is the discrete mathematics course, Yadavji, and this is not for ECE background. This is for computer science branch students for GATE examination. Okay. So, rules of inference. But why do we use rules of inference? That's what we'll discuss in a while. But before that, this is a brief introduction of myself. My name is Vishal Rawatiya. I have 10 plus years of teaching experience. Following are the achievements and areas of expertise. Okay. So, there is an announcement for all of you. Tonight at 7:30 p.m., Abhinav Negi sir is going to conduct a workshop in which he will discuss a master plan to conquer GATE 2024 exam in just 6 months. Okay. So this workshop is absolutely free. If you have just started preparing or if you are having any doubt whether you will be able to complete your syllabus, whether you will be able to score a good mark in the GATE 2024 exam in just 6 months or not, then this is a workshop which is for you. This will be an interactive workshop. So if you guys are having any doubt, you will be able to ask. So it's free. You just need to download the application and you will be able to watch it. Okay. For EAC students, for students who are preparing for EAC, for the ECEE or instrumentation branch, so BYJU'S exam prep is coming up with a series in which our dear faculties are going to discuss previous year questions of EAC from 2017 to 2023 or so. Basically, these are 7-year questions of EAC, and this series will be live from tomorrow, that is from 2nd of August. Okay, so let's start with the session. Okay, BYJU'S. Okay, Yadavji. Okay, so what is an argument or inference? So please try to understand that why do we use these rules of inference. First of all, let's try to understand. So what is an argument? Argument is something that someone is saying that if these are the things, then an inference or conclusion will be there, that this conclusion will also be true if the given statements are true. So let's try to understand a simple rule that if I say that if today is Vishal's birthday, it's my name. Then today is, let's assume any date. What's the date today? 1st August. So there is one the statement which is given. So it is the statement 1. The statement 2 which is given is that today is 1st August. Now I am saying that if these two statements are given, then can I conclude this particular thing that today is Vishal's birthday? Tell me. Please tell me. Very basic statement. So this is what we call argument. This is what we call argument, that an argument is given that if the given statements are true, then the conclusion will also be true. What do I mean by inference? That from the given statement, you can infer the validity of this particular statement. That's what the meaning is. Now tell me whether this argument is true or false. So generally, if you are thinking as a human mind, then you will eventually say that this statement is true. But please try to understand, if today is Vishal's birthday, then today is 1st of August. This is the implication. If today is Vishal's birthday, then 1st of August. And the another thing which is given, this is the first statement. Another statement which is given is that today is 1st of August. Right? Now, can you conclude based on this that today is the Vishal's birthday? So, let's try to understand if then. If P is true, P implies Q, this is P implies Q, and this is Q. Right? So, P is that today is Vishal's birthday, Q is today is 1st of August, and this Q is today is 1st of August. So, if P implies Q is true and Q is also, and P implies Q is true and Q is true, then can you say, can you comment upon the truthness of this P? So, please try to understand this. P implies Q and Q is given. So, can you say that P will be true? No, sir. Please try to understand. If this Q is true, if this Q is true, then here also this Q will be true. Then for this implication to be true, there is no restriction on P. Yes or no? No restriction on P. We have already defined that if P implies Q is true, then P must be true, and I mean, if P is false, then the whatever the value of Q, P implies Q will be true, and if Q is true, then whatever the value of P is, P implies Q will be true. So it is given that Q is true. So if Q is true, then for P implies Q to be true, there is no restriction on P. It may be true, it may be false. It may be true, it may be false. So generally, as a if you generally try to perceive this statement based on the basic English language, then you will eventually say that this statement is true. But no, if you think in terms of mathematical logic, then this statement is false. So that's what the validity of argument or the validity of inference means. If the conclusion, so this is what your conclusion, this is your conclusion. If the conclusion can be followed or conclusion will be true whenever the given statements of the argument are true, then we say that the argument is valid, otherwise the argument is invalid. So please try to understand. So why have I given this example? Because generally when I define in terms of premises, then people will not understand it. So let's try to understand the statement that a set of premises P1, P2, P3 up to Pn. So these are nothing but the propositions. So if you ask that, sir, what are this P1, P2, P3 up to Pn? So P1, P2, P3 up to Pn are nothing but the propositions. They may either be true, they may be false, right? So if a set of premises P1, P2, P3 yields another proposition Q is called an argument. So that's the simple thing which I have defined, that if you have P1, if you have P2, etc. up to Pn, so based on that, therefore Q. So what does it mean? That if P1 is true, P2 is true, P3 is true, up to Pn are true, therefore Q will also be true. This is an argument. Now this argument may be valid, this argument may be invalid. So that's what we need to check. So argument may be valid or invalid. When do we say that the argument is valid? So if conclusion Q can be inferred from the set of premises by applying some rules of inference along with the equivalences, because equivalences are always valid. So by applying some rules of inference and equivalences, then the argument is said to be valid, otherwise invalid. So if somehow you can prove that whenever this P1, P2, P3 up to Pn are true, then Q will also be true, then this argument is valid, otherwise the argument is invalid. So for that, what we need to use to prove that, we need to use the rules of inference. So what are the different rules of inference? That's what we are going to discuss in today's session. So first of all, let's try to understand. These are just the three notation which represents the same thing. So if we are saying argument that P1, P2, P3 up to Pn yields, so this is nothing but yields Q is valid. So argument is valid means what? Argument is valid means whenever P1, P2, P3 up to Pn are true, then Q will also be true. Then only the argument will be valid. That's what I said. Now please try to understand the logical implication. Please try to understand the logical implication. So the propositional formula P logically implies Q means what? Whenever P is true, if Q is also true. Whenever P is true, if Q is also true, then we say that P logically implies Q. The similar thing can also be applied here, that whenever P1, P2, P3 up to Pn are true, Q is also true. Therefore, P1, P2, P3 up to Pn logically implies Q. Same meaning? Getting the idea? So, whether you get the question in the form of argument, or you get the question in the form of logical implication, or you get the question in form of tautology, all will be same. What does it mean? Why tautology? When we say P tautologically implies or P logically implies Q, then if P logically implies Q, then P implies Q is a tautology. Yes or no? Why? Sir, if you are saying that P logically implies Q, means whenever P is true, Q is also true. So, there is no possibility that P becomes true and Q becomes false. This is the only case when P implies Q can be false. This is the only case when P implies Q can be false. So, if P logically implies Q, then P implies Q is eventually a tautology. So, here these are the separate propositions on the with respect to implication. With respect to implication, on the left hand side there should be one propositional formula, and on the right hand side there should be another propositional formula. Therefore, we'll combine all these propositions. We'll combine all these propositions with the help of conjunction to define a unique propositional formula on the left hand side, and let's assume that this Q is the unique propositional formula on the right hand side. So, if P1, P2, P3 up to Pn all are true, then this P1 and with P2 and with P3 up to and with Pn will also be true. Yes, obviously, because if all the statements of the conjunctions are true, then the conjunction will eventually return true. So if we are believing that P1, P2, P3 up to Pn are true, then this conjunction will also be true. Therefore, this implies Q is a tautology. This implies Q is a tautology. When if the argument is valid, then only it will be a tautology. If the argument is invalid, means whenever P1, P2, P3 up to Pn are true, if there is any case when Q can be false, then there will be a possibility that this LHS becomes true and this RHS becomes false. Therefore, it will not be a tautology. Therefore, it will not be a tautology. So, these three statements are equivalent, that argument is valid or logical implication is true or logical implication is valid, or the simple implication is a tautology. All of them are having the same meaning. Don't get confused that, sir, you have only taught us how to check the validity of an argument. If a question comes in form of logical implication or in form of tautology, then what do? All of them are same. If you feel that it will be easier to prove that P1 and P2 and P3 up to Pn implies Q is a tautology, if it is easier to prove, then prove this. If you have proven this, then it means that the argument is valid, and similarly it means that the logical implication is also valid. Similarly, if you feel that it will be easier for me to prove that logical implication is valid, then prove that logical implication is valid, and it will mean that argument is valid as well as implication is a tautology. Similarly, if you find it that it will be easier for me to prove that the argument is valid, then prove the validity of the argument and the other two statements will hold true. That's the logic. Clear? Anyway, so let's try to understand that all these three statements are having the same meaning, but anyway, to prove the argument, you will have to use the rules of inference. So let's try to understand that what are the different rules of inference. So the very first thing is, these are just the names, don't worry about them. There are some important rules of inference about which I'll tell you, but this implication is quite simple. What does it mean? If somebody is telling you that P and Q is true, if somebody is telling you that P and Q is true, then from here you can eventually say that yes, if P and Q is true, therefore P will be true, as well as if P and Q is true, therefore Q will also be true. Therefore Q will also be true. So what does it mean? If something is available in the form of conjunction in the premises, if the given statement is in the premises and it is available in the form of conjunction, then you can actually simplify that. You can actually simplify that. So I'm saying that these things are valid. If you look at the things, then you will eventually say that this is also a rule of inference. Yes, this is also a argument, but yes, there's also an argument, but we don't need to prove this argument. These are already considered as valid arguments. So these are the rules. So basically we have already proven the validity of some arguments and we are using them as a rule. So don't say that what's new in this, that whenever P and Q is true, therefore P will also be true. No, we know that there is nothing new in this particular thing, but this type of rule can directly be used when you are trying to prove the validity of an argument. That's what it means simply, right? Now, if I say this is valid, then similarly you can also say that if P and Q, then P and Q logically implies P is valid. This will also have the same meaning. Or I can say P and Q implies P is a tautology, right? All of them are having the same meaning. So from now on, I'll not define this two because the meaning will be inherent that yes, whenever the argument is valid, other two will eventually follow. Other two will eventually follow. So what is addition? So please try to understand. If the operation is conjunction, then you can simplify it. But when you are talking about addition, so please tell me if somebody is telling you that P is true. If somebody is telling you that P is true, then can you add another proposition Q along with P? Can you add another proposition Q along with P with an OR operation? With an OR operation? Yes, sir, because P is true. So here also P will be true. Whatever the value of Q is, P or Q will remain true. P or Q will remain true. So when proposition is true, you can add anything with the disjunction. New propositions can be added. In the conclusion, using disjunction. Obviously, you cannot say that if P is true, therefore P and Q will also be true. No, because we don't know whether Q is true or not. Q may be false. Q may be false. So if Q becomes false, P and Q will become false. So this thing is invalid. So you cannot add another proposition into a given proposition using the conjunction, but you can add a new proposition with the given proposition using the disjunction. Clear? So this is valid. So you can add anything using the OR operation. Okay, so this addition. Now the conjunction. Conjunction says what? If there are two different arguments P and Q in the set of premises, two things are given in the set of premises. One is the proposition P, another is the proposition Q. So when you know that P is true and you know that Q is true because they are in the set of premises, so we assume that all the propositions in the set of premises are true. We assume that all the propositions in the set of premises are true. Then only we check for the truthness of the conclusion Q. So please try to understand, if P is true as well as Q is true, therefore can we add them using the conjunction operation? Can we add them using the conjunction operation? Sir, we know P is true as well as Q is true. So whenever P and Q both are true, then the conjunction will always return true. Conjunction will always return true. So yes, sir, this is also a valid argument. This is also a valid argument. Therefore, it can be directly used as a rule. Clear? Okay. So now the next thing is disjunctive syllogism. What do I mean by disjunctive syllogism? So disjunction. So please try to understand. You cannot add. You cannot. So please try to understand. Conjunction is okay. That's you can actually perform the conjunction of two truth statements. But if disjunctive syllogism means what? If you have P or Q. Let's try to understand. You have two statements P or Q. What does it mean? Either P will be true or Q will be true for P or Q to be true. Clear? Now, at the same time, if I tell you that P is false, What does it mean? It means P is, negation P is true. So this is a premise. This is a premise. So you will consider that negation P is a premise, therefore negation P is true. So if negation P is true, therefore P has to be false. Therefore P has to be false. So if P or Q is true and P is false, therefore can you directly say that Q will be true? Please tell me. Please tell me, will it be valid? Yes or no? What are you guys doing? I am saying if P is true, P or Q is true, P or Q is true, and another proposition is saying that negation P is true, means P is false. So for when P is false, this P or Q to be true, Q must be true. Q must be true. So yes, this will also be a valid statement. Clear? So this is known as disjunctive syllogism. Why disjunction? Disjunctive syllogism because it is defined with respect to this disjunction operation. It is defined with respect to disjunction operation. Can you define the syllogism with respect to conjunction? No, sir. If somebody tells you that P and Q is true, if somebody tells you that P and Q is true, and at the same time I say negation P is true, then this is wrong hypothesis. Yes or no? Anyway, if you are saying P and Q is true, then P cannot be false. If you are saying P and Q is true, then P cannot be false. Therefore, we cannot define a conjunctive syllogism with respect to this. Clear? Chalo, let's try to understand that if at all we want to define the conjunctive syllogism, then we will have to do something else. Sir, we cannot use this particular thing, but De Morgan's law, we know the concept of De Morgan's law. So we are trying to define the conjunctive syllogism. It means the operation which will be directly available in the premises will be AND operation. So if I write it as P and Q, if I write it as P and Q, so this is the conjunction. But we cannot directly use anything. Therefore, I'll simply say that let's assume that convert it negation. Let's use a negation. So if you are using negation, then it eventually becomes what? Sir, if you are using a negation, then it eventually becomes OR because of De Morgan's law. So please, for the purpose of understanding, just try to understand that this will become negation of P or with negation of Q. At the same time, so let's look here. If negation of P or with negation of Q is true, then either negation P is true or negation Q is true. Means either P is false or Q is false. Either P is false or Q is false. If somebody is telling me that okay, P is true, so you are saying negation of P or with negation of Q is true, means either P is false or Q is false for this statement to be true. Now, someone is saying that P is true, then Q must be false, yes or no? So that's with respect to disjunction. So the understanding is with respect to disjunction, but the name of the syllogism is conjunctive syllogism. Therefore, I'll represent using the conjunction operation and I'll define a P here. So if it is given that negation of P conjunction with Q and P, therefore negation Q must be true. Clear? Just to, I'm just giving this information to remember that okay, syllogism is okay, that disjunction, if a disjunction is there, then ultimately one of those to be true. If one is given as false, then the another one needs to be true. Here, with respect to AND operation, this will hold true. So please, this you must think that sir, we can eventually derive this. But the idea is that you must remember this particular thing, that what is our disjunctive syllogism, what is our conjunctive syllogism, because the question may be of the type that if we try to convert a given particular statement into this particular conclusion, then what are the different rules which we are applying? Clear? So you must know the names, that okay, what is the meaning of this particular thing. So next one, so this is most important. Most of the time, two things will be used in the propositional logic. One thing is P implies Q is equivalent to negation of P or with Q. I have already in the yesterday's session, I have already defined the truth table for P implies Q and negation of P or with Q, and we realize that the truth table for P implies Q is exactly same as the truth table for negation of P or with Q. Therefore, these two statements are equivalent. Now, what is modus ponens? Modus ponens says that if P implies Q is true, so it is with respect to implication. If P implies Q is true and P is also true, if P implies Q is true and P is also true. So please try to understand. Somebody is saying that this implication P implies Q is true, right? And if P is also true, then you all know that for this implication to be true, P implies Q to be true. Whenever P is true, Q must be true. Whenever P is true, Q must be true. So therefore Q is valid. This is modus ponens, and in most of the questions related to logical implication or the questions related to the concept in which you need to prove whether the argument is valid or invalid, in most of the questions this particular rule will be applied, right? Now that's okay, that this is good enough, but fallacy of assuming the converse. So generally what happens, in the hurry, the student will eventually use this rule, which is invalid. So if you are saying P implies Q and Q, P implies Q and Q, therefore P. So you are assuming the converse of the original statement. You are assuming the converse of the original statement. Here it says P implies Q and P, but you are assuming P implies Q and Q, and you are saying that P is valid. No, it cannot be valid. If Q is true, if Q is true, here also if Q is true, then there is no restriction on P. I just explained the concept. If today is Vishal's birthday, then today is 19th of August, and today is 19th of August. So the statement cannot conclude that today is Vishal's birthday. But if it is opposite, then you can always conclude the validity of the statement. Clear? So may be true, may be false. Clear? May be true, may be false. Therefore, this is invalid. So please don't ever consider P implies Q and Q as P. If you are in hurry, then you may eventually commit such mistakes, but this is wrong. Clear? Okay. So one is modus ponens, another is modus tollens. So these are two people who has given the rules. Therefore, the names of the rules are based on their name. So modus tollens, it says P implies Q is true and negation Q is true. P implies Q is true and negation Q is true. What does it mean? P implies Q is true and negation Q is true. That is, Q is false. If negation P is true, then this Q must be false. If Q is false, then for this implication to be true, P should also be false, because if this P becomes true, then P true implies false will become false. But we know that P implies Q is true and Q is false because of this particular proposition. So if Q is false, P has to be false. That is, negation P must be true. That is, negation P must be true. Clear? So don't just remember, but try to understand as well that what is actually happening. Right? Now, similarly, the fallacy of assuming the inverse. You may say that P implies Q is true and negation P is true, therefore negation Q will be true. No, it is invalid. Invalid. Please try to understand. If you are saying P implies Q is true and negation P is true, means P is false. So if P is false, for the implication to hold true, there is no restriction on Q. Yes or no? It may be true, it may be false. What the idea? So it is not guaranteed that Q must be false. It is not necessary that Q must be false. Therefore, this statement is invalid. Clear? So this is the fallacy of assuming the inverse. So rather than assuming P implies Q and negation Q, you are assuming P implies Q and negation of P. Negation of P. So that's okay. Now, next one is transitivity. This is the easiest one. What does it say? If there is one proposition P implies Q, but the understanding is more important. Another one says Q implies R, P implies Q and Q implies R. Then you all know by transitivity P implies Q and Q implies R. Therefore, P implies R will be true. Therefore, P implies R will be true. But please try to understand, sir, what are the different scenarios which are possible? Sir, if P is false, if P is false, then this P implies Q is guaranteed to be true. Then this P implies Q is guaranteed to be true, and we all know that Q implies R is also true. Q implies R is also true. But anyway, you don't need to think about the validity of this Q implies R. As long as this P is false, this overall statement will remain true. Now, let's assume that what happens if P is true? So if P is true, and we are saying that P implies Q is true, therefore, whenever P is true, for P implies Q to be true, Q must also be true. Now, because this Q is true, therefore, eventually this Q will also be true. Now, if this Q is true, then Q implies R to be true, R should also be true. That is, whenever P is true, R is guaranteed to be true. So, when P is false, R can be true or false, there is no restriction, and P implies R will be true. But similarly, based on the given condition, whenever P is true, Q will also be true, and because of Q, this R will also be true as Q implies R is true. Therefore, whenever P is true, R will also be true. Therefore, this will also be true. That means, whenever the propositions of the premises are true, this conclusion will also be true. Therefore, it is valid. Clear? Next, so this is transitivity. Next one is dilemma. So, I'm in confusion that what is actually happening. So, let's try to understand. If I say P implies Q is one proposition and P implies R is another proposition. P implies Q, P implies R. P implies Q, P implies R, and if I say that negation of Q or with negation of R, kindly check what will be the output of this, otherwise we'll reassume. Please check. If P implies Q is true and P implies R is true, at the same time negation of Q or with negation of R is also true, then can we say anything about P? Can we say anything about P? Please check about the validity of the statement. Confusion. P implies Q, Q implies R. Just 1 minute. So, Q is false, either Q is false or R is false. So, if Q is false or R is false, so you are saying that P implies Q is true. You are saying that P implies Q is true. Yes. And P implies R is also true. Yes, P implies R is also true. But at the same time, you are saying, sorry. This is all, we'll use this as well, but this is something else. See, even with time, dilemma. So it's normal one that if I say P implies Q, or yeah, P implies Q and R also implies Q. P implies Q as well as, guys, please check, P implies Q and R is also implying Q. And apart from that, I am saying that P or with R is true. P or with R is true. So, what will be the valid thing? So, let's look at this. Either P will be true or R will be true for this P or with R to be true. So, it's a dilemma that either P is true or R is true. Which one is true? I don't know. But please, if P is true, then for P implies Q to be true, Q must be true. If R is true, then also for R implies Q to be true, this Q must be true. And if both P and R are true, then also Q must be true. So this will yield Q and this is valid. This is valid, right? So it's a dilemma, but please try to understand. This both are yielding the same conclusion. I mean, the consequent of P implies Q and R implies Q is same. But what if the consequents are different? So please try to understand this, and it is known as constructive dilemma. It is known as constructive dilemma. So when it is a simple dilemma, please try to understand this. When it is a simple dilemma with respect to implication, the consequent will be same. With respect to implication, the consequent will be same, and you will have the disjunction of the antecedent. You will have the disjunction of the antecedent. But let's assume that these consequents are different with respect to implication. So if I say P implies Q, P implies Q and Q implies R. Sorry. Why R? What am I doing? This P implies Q at the same time. We need the disjunction of P and Q. So let's say P implies R and Q implies S. Yeah, that will make sense. So P implies R and Q implies S. Please try to understand. Here also these two things are different, but the consequent are same. Consequent are same. Here we are saying consequents are different, and now we are saying the disjunction of the antecedent. The disjunction of the antecedent. Can we check the validity of anything related to R and S? Please try to understand. Sir, if P is true, see, let's look at this. If P is true, then here also P will be true. And if this P is true, then R is guaranteed to be true. If P is true, then R is guaranteed to be true. Similarly, if Q is true, then S is guaranteed to be true. If both P and Q are true, then R and S both are guaranteed to be true. Both P and Q cannot be false at the same time. Both P and Q cannot be false at the same time, otherwise this P or Q will become false. So at least one of them will be true. At least one of P or Q will be true. If any of P or Q is true, then it is guaranteed that either R will be true or S will be true. Therefore, we can say that R or with S is guaranteed to be true. Clear? See, in terms of remembering, it may be difficult, but once you have the implication in front of you, you will be able to visualize that what is actually happening. That you are saying that okay, P implies Q, R implies Q, and there is an union of antecedent. So if the union of antecedent is true, then at least one of them will be true. If any one of them is true, then for implication to be true, RHS should also be true. Therefore, Q is true. Here we are having the consequents are different, and we are having the conjunction of antecedent. So with respect to conjunction of antecedent to be true, at least one of the antecedent will be true. At least one of the antecedent will be true. So if at least one of the antecedent is true, then corresponding consequent must also be true. Corresponding consequent must also be true for this implication to be true. Therefore, the union of the consequent is guaranteed to be true, because at least one of the consequent is guaranteed to be true. Either both of them may also be true, but at least one of them is guaranteed to be true. Therefore, the union of those two is guaranteed to be true. Clear? Similarly, destructive dilemma. So when I say constructive dilemma, so in terms of constructive dilemma, we are taking the union. Please try to understand how to remember. With respect to constructive dilemma, we are taking the union of antecedent. We are taking the union of antecedent. So constructive side, we are thinking from the constructive side. In destructive dilemma, we'll do something else. So please, let's look at this. P implies R, Q implies S. So the implications are exactly same. P implies R and Q implies S. But rather than saying the disjunction of antecedent, we are talking about the disjunction of consequent. We are talking about the disjunction of consequent. But please try to understand, if I say that R and S is true, then ultimately we'll talk about the truthness of that, because if R or S is true, then there will be no restriction on P and Q, because if RHS is true, then for implication, if consequent is true, then there will be no restriction on the antecedent. It can be anything. So think when the consequent is false. Therefore we'll just say negation of R union with negation of S. What does it mean? Either R is false or P is false. Either R is false or P is false. So please try to understand this. If R is false, destructive side. So don't worry, sir. That's why we call it destructive dilemma, because we are thinking from the opposite side by making the statement as false, by considering the statement as a false statement. So negation, either R is false or S is false. So if R is false, then for P implies R to be true, P must be false, right? If S is false, then for Q implies S to be true, Q must be false. If both R and S are false, so it may also be possible that R is false as well as S is false. So if both R and S are false, then it is guaranteed that P will be false as well as Q will be false. In this case, please try to understand. When I say P, either P will be false or Q will be false. Either P will be false or Q will be false, or both of them will be false. So in that particular sense, negation of P or with negation of Q will be true. So if P is false, then negation of P will become true, and if Q is false, then negation of Q will become true, and if both of them are false, then negation of P will become true as well as negation of Q will become true. So yes, if P implies R is true, Q implies S is true, as well as negation of R or with negation of S is true, then negation of P or with negation of Q will also be true, and this will become a valid argument. Getting the idea? So please, let's try to understand that. It may be simple enough. Some of you may think that, sir, we already know this, right? But try to derive them. And just try to understand that why these different names are given. So destructive dilemma, because we are thinking by considering these statements to be false. Constructive dilemma, when we are considering these statements to be true. That is, and when we are considering true, you need to think in terms of antecedent. The normal dilemma, that is, you don't need to think in terms of too many things. It's a normal dilemma. In this particular case, the consequent of the implications will be same. So simple enough. Now, non sequitur. So it's nothing but you cannot comment on the validity of a random thing. What does it mean? It means if somebody is telling you that P is true and Q is true, then you know only about P and Q. So you can only comment about the things which are available in the set of premises. You cannot randomly select a proposition which is not present in the set of premises and try to comment on the validity of that particular proposition. No. So P is true, Q is true, therefore R. You cannot say anything about R. So this is invalid. So whenever you find something like this, that the proposition is or the set of premises are talking about something else and the conclusion is containing completely opposite information, so don't even think about that. Simply say that the thing is invalid. Clear? Now this is important, this is invalid, not a valid. So general rules of inference are for defining the validity, but this non sequitur, fallacy of assuming the converse, and fallacy of assuming the inverse are the three rules which are used for defining the invalidity of the given argument, that the argument is not valid, right? So that should also be there in our form. Now please try to understand that how do we use these rules of inference. So please, let's look at this. Sir, which of the following is false? So this is one statement, that this is one proposition or the one propositional formula in the set of premises. There is another propositional formula in the set of premises, and this is your conclusion. So you can think of it like this, that this is a premise P1, this is a premise P2, and this is your conclusion. Got the idea? So something like this will be available, right? So I can also rewrite this particular thing in different manner. So I can also say P implies Q implies R, comma, P and R yields R. So the question may be in this particular form also, or the question may be in this particular form also. P implies Q implies R and P and R implies R is a tautology. Is valid or logically implies R. So this question can be asked in multiple forms. So if it is asked in this particular manner, then also you need to do the same thing. If it is asked in this particular manner, then also you need to do the same thing. If it is asked in this manner, then also you need to do the same thing. So please try to understand that how do we apply the rules of inference. So I am describing with respect to option 1 that if you have something like P implies Q implies R, there is one premise and another is P and R. So these are the premises. Now let's try to apply the rules one by one. Let's try to apply the rules one by one. So do you see that here we are having a conjunction? Here we are having a conjunction. So we can apply the rule of simplification. So when you are solving this, you need not write this, but if we apply, so we are solving just one question, therefore let me write everything. That if we apply the simplification, then we can actually say that I can write P and with R as P as well as P and R with as R. So got the idea? So the new premise will eventually become what, sir? P implies Q implies R is one proposition or one propositional formula. P is another propositional formula and R is another propositional formula, right? So because of simplification, you can eventually separate the propositions or propositional formulas which are related with the help of connective conjunction. Now, what else? So at this point of time, I realize that okay, if this is P and if I consider this as a new thing and this is P, so please try to understand P implies whatever this is and P. So on this too, can I apply the concept of modus ponens? Can I apply the concept of modus ponens? Yes, sir. This is P. I am considering this whole thing as Q and this is again P. So P implies Q and P, therefore P will be true. Sorry, Q will be true. P implies Q is true and P will be true, therefore Q will be true. And what is Q here? Sir, Q here is nothing but Q implies R. Q here is nothing but Q implies R. So whenever P implies Q implies R is true and P and R is true, then P implies Q implies R will be true as well as P will be true as well as R will be true. Now because P implies Q implies R is true and P will be true, therefore Q implies R will also be true. Now you know that yes, because of modus ponens, Q implies R will be true. So again apply the modus ponens on these two things, that we know that Q implies R will be true as well as R will be true. So if we apply this modus ponens again, then because of this modus ponens, Q implies R is true and R is true. So can we say that Q will be true? Please look at this. Sir, if it is R, then cannot be used. And anyway, some printing mistake is there. Why? It's very simple reason. The concept is quite simple, that if you are already saying that P and R is true, so from here P and R is true, therefore it is guaranteed that R will be true. So there is no big deal. But let's consider it as Q. Because what you need to prove, if it is already given in the set of premises that it is already true, then nothing much needs to be done. So please make it Q, so it will become a valid question. Just by mistake I have written it as R. So okay, But yeah, you cannot use any wrong rule. Otherwise, what will I be doing? I will be using the fallacy of assuming the converse. I'll be using the fallacy of assuming the converse, and in that regard, it will become invalid because Q implies R and R cannot give you Q. Q implies R and R cannot give you Q. But anyway, we need to talk about the validity of R. Anyway, we need to talk about the validity of R, and we will not even require all this simplification. The simple rule of simplification, that is P conjunction R will eventually yield R, and we don't need to think about anything else. So let me change the same thing at all the places, right? So when this is Q, so Q implies R is true and Q is true. Q implies R is true and Q is true. Therefore, R will be true. And that's what we wanted to prove. That's what we wanted to prove. Therefore, this statement, the given statement is true. In this format, it is true. In this format, it is true. But obviously, if it is R, then also it will be true. Okay, let's look at the option B. Let's look at the option B. You don't need that much amount of time. I'm just trying to explain the concept. That's why I'm taking the time because it's a very fast question. And let's look at this. Negation of R implies S implies negation of T is one thing. Negation of R or with W is another thing. Negation of P implies S is another thing, and negation of W is another thing. So these are four premises. These are four propositional formulas available in the premises, and we need to check the validity of T implies P. So we just need to see whether T implies P will be true or not when all these things are true. When all these things are true. So we will consider that the all the propositions in the given set of premises are true. So let's try to understand this. First of all, sir, we don't know about negation of R as of now. We don't know about negation of P as of now. But we know one thing. Negation of R or with W is true and negation of W is true. What does it mean? Sir, negation of R or with W is true and negation of W, that is W is false. So if here this W is false, if this W is false, then because of dilemma, you will eventually say that negation R will be true. What the idea? Getting the idea? If negation R or with W is true and W is false, then if W is false, if this W is false, then for negation of R or with W to be true, negation of R must be true, right? So this is negation of R. Now, by applying the modus ponens, now you know that negation of R is true. So if it is P, it is Q, and it is again P. So P implies Q and P will eventually yield S implies negation of T. S implies negation of T. Please try to understand this. What, sir? S implies negation of T, and here we have negation of P implies S. So we can always use the concept of equivalence. We can always use the concept of equivalence. So please try to convert this. Please try to convert this. Negation of S implies P. P implies Q is negation of Q implies negation of P. P implies Q is negation of Q implies negation of P. Yes. So I can eventually convert negation of P implies S as negation of S implies negation of P. Now negation of P will become P. Similarly, I can convert this as T implies negation of S. T implies negation of S. Now on these two things, by the rule of transitivity, please try to understand. T implies negation S and S negation of S implies P. So P implies Q and Q implies R. That means P implies R, that is T implies P will be true. That is T implies P will be true. So when you are using the rules of inference, please keep in mind that what you need to prove. Please keep in mind that what you need to prove. Otherwise, you can randomly apply the rules of inference and you will not know that in which direction you are going. So please bear in mind that whenever you are applying the rules of inference, try to think that what we are actually trying to derive. Similarly, now here negation of P and with Q. So From here negation of P will be true as well as Q will be true, and because Q is true and this is true, therefore P implies R will be true. Now see, P implies R is true and negation of P is true, then we cannot comment about the validity of negation of R. It will be fallacy of fallacy of assuming the inverse. It will be the fallacy of assuming the inverse. So let me remove this so that I'll be able to explain. I guess one question will be sufficient to explain all the concepts of rules of inference. Let's look at this. What's a negation of P and with Q? Color. Another thing is Q implies P implies R. Forget about this negation of R, that's what we need to conclude. So we are trying to say that R will be false. But first of all, because of this, by simplification, we can say that negation P will be true as well as Q will be true. And this is already true. Now, Q implies something and Q. So P implies, so you can consider it as P. So P implies Q and P, therefore by modus ponens, you know that P implies R will be true. Now the idea is, sir, P implies R is true and negation of P. P implies R. If P implies R is true and negation of R is true, then negation of P will be true. P implies R is true and negation of R is true, then negation of P will be true. But here it is nothing. If you are trying to yield, negation of R, then this thing is invalid. Why? Using which rule? Fallacy of assuming the inverse. Fallacy of assuming the inverse. By this particular rule, you know that from this two things, that if P implies R is true and negation of P is true, then you cannot comment on the validity of R, that whether a negation of R will be true or negation of R will be false. It may be true, it may be false. Therefore, this conclusion cannot be yielded from the given set of premises. If the conclusion cannot be yielded from the given set of premises, therefore this statement is false. This statement is false, and that's what is being asked in the question, that which one is false. So option C will be the right answer. Option C will be the right answer. The last one is quite simple. This is P and P implies R. This two will give you R. Now please try to understand. Q or with negation of R, and you are saying R is true. So negation of R guaranteed to be false. If R is true, then negation of R is guaranteed to be false. If negation of R is false, then for Q or with negation of R to be true, Q must be true. So this is also true. So it's nothing but the simple use of modus ponens and dilemma. Clear? Now please try to understand. Most of the time, student will find it difficult to prove whether the implication holds true or not. You may also think, sir, how do we eventually think of those many things at the same time, that yes, this will yield S implies negation of T, then S implies negation of T, and this is negation of P implies S. So first I need to convert it to negation of S implies P, and then S implies negation of T needs to be converted into T implies negation of S, and then it will yield T implies P. It's always easy to think of a single propositional formula, that whether this propositional formula will hold true or not. In terms of implication, it always becomes complicated. So there is one rule which is known as conditional proof rule. What does it say? It states that proof of argument P1, P2, P3 up to Pn
yields Q implies R. Please try to understand this. This is very simple concept, but can be used very efficiently. So it states that the proof of argument P1, P2, P3 up to Pn yields Q implies R is the same as proving the argument what P1, P2, P3 up to Pn. Now what am I doing? So we are just placing the antecedent of this implication in the hypothesis. What are we doing? We are placing the antecedent of the implication which needs to be derived in the hypothesis, that okay, we will consider this Q here and we will try to yield R from this. Please, why does it hold true? Why does it hold true? Please try to understand that we are simply saying that whenever P1, P2, P3 up to Pn are true, we are saying that whenever P1, P2, P3 up to Pn are true, then Q implies R will also be true. So let's assume that it is true. Let's assume that whenever P1, P2, P3 up to Pn are true, Q implies R is also true. Now you know that for Q implies R to be true, if Q is true, then R should also be true. If Q is false, then R can be true or false. R can be true or false. So it may be possible that when P1, P2, P3 up to Pn are true, then Q may be true and Q may be false. But whenever Q is true, R is guaranteed to be true if Q implies R is true. Whenever Q is true, whenever Q is true, R is guaranteed to be true because Q implies R is true. So just do a simple change in the argument, that rather than proving that P1, P2, P3 up to Pn yields Q implies R, just include this antecedent of the implication in the hypothesis and try to prove that P1, P2, P3 up to Pn and Q will yield R. So why? Because if P1, P2, P3 up to Pn are true and Q implies R is also true then for all the cases when Q is true, R is guaranteed to be true. So just do one transition that also include this Q in the hypothesis and prove that R will be true. Clear?
Good morning, Swati. Right? So it states that the proof of this given argument, if you want to prove this, then it may look difficult because of the implication in the conclusion. So you can eventually change that implication into a single propositional formula by placing the antecedent of that implication into the set of hypotheses. So P1, P2, P3 up to Pn, comma U implies R will give you the same thing, that P1, P2, P3 up to Pn yields Q implies R. There's no difference. So let's try to understand this with the help of an example. Okay. So because sometimes it will be completely impossible to, or completely very typical to prove that Q implies R or any implication yields from the given set of premises. So this is one example of that particular type. So this also gives you one information that if the statements are, if the conclusions or if the arguments are given in the form of statements, then first you need to convert them into propositional formula. So let's try to understand. If A works hard, then B or C will enjoy themselves. So first let us define that, okay, A is a proposition which represents that A works hard. A is used to denote that A works hard, and you will always be able to do this, just like I did, that today is Vishal's birthday. That means V. So I just said V. So you can give any name. So A works hard. Now B is related to enjoyment. So just say B represents B enjoy himself. C
is also related to enjoyment. So C says C enjoy himself. If B enjoy himself already considered, then A will not work hard. A is related to working hard. If C enjoy himself, then D will not enjoy himself. So there's one more thing, which is D. So this D is talking about person D. So D represents that D enjoy himself. D is related to enjoyment. So just say D enjoy himself. The inference is that given this three statement, you can infer that if A works hard, then D will not enjoy himself. So let's try to convert this argument in the propositional in the form such that it is with respect to a propositional formula. So if A works hard, so first one is saying what? Please try to understand. If A works hard, so if A works hard, so A implies A works hard. So if A works hard, then B or C will enjoy himself. So either B will enjoy himself or C will enjoy himself. So what's the idea? Either B will enjoy himself or C will enjoy himself. Clear? So this is the first statement. If A works hard, then either B or C. If A works hard, then either B or C. Second says what? Second says, if B enjoys himself, so B enjoy himself is B. If B enjoy himself, then A will not work hard. Jealousy. You are enjoying, I will not work. So if B enjoy himself, then A will not work hard. Now please try to understand. A represents that A will work hard. A represents that A works hard. Now, if you are trying to say that A will not work hard, then you will have to use negation of A. That is, if B enjoy himself, then A will not work hard. Clear? Now, statement 3. So you just need to convert these statements based on the propositions which you have just defined. Clear? The last one is, if C enjoys himself, if C, and C eventually represents C enjoy himself. So if C enjoy himself, then D will not enjoy himself. So D represents D will enjoy himself, but you are saying D will not enjoy himself, that is negation of D. That is negation of D. Now, let's try to understand that the conclusion, therefore, you are trying to prove that if A works hard, that is, if A works hard, then D will not enjoy himself, then negation of D. Then negation of D. Got the idea? So, the concept is quite simple. Now, you have the premises in your hand. So, what are the premises? So, premises are A implies B or C. This is the first premise. Another premise is B implies negation of A. Another premise is C implies negation of D. C implies negation of D. And we are trying to prove this. Now, please try to understand. Hi, Lucas. Hi. Okay. So if you are in first year, then you will eventually study discrete mathematics in your second semester, I guess. Generally, the discrete mathematics is studied in the second semester in most of the universities. Anyway, so if you have any query, please let me know. So please try to understand. Can you do anything based on these propositions? Please. I just told you that sometimes it may be difficult to start if the result is in the form of implication. That's why I have explained this particular concept. Otherwise, if the statement is of this particular type, in which even if you are trying to check the validity of an implication, then also it was not too difficult, because you were able to start from somewhere in the given set of premises. But in this particular question, you will not be able to do anything, because you will just think that A implies B or C, but modus ponens cannot be applied because there is nothing related to A. Even if you convert it into A implies negation of B, then also it is not useful, because these two things must be exactly same. With respect to modus ponens. Apart from that, we cannot think of anything or any rule which can be directly applied, So my suggestion is, at this point of time, my suggestion is to use the conditional proof rule. Conditional proof rule will say what? That also include the antecedent, of the implication in the premises, and try to prove the validity of the consequent, that is negation of D. Now it will become simple. Is it visible? Yeah. Now try to prove that if try to prove this: A implies B or C, comma, B implies negation of A, C implies negation of D. Also consider the antecedent of the implication in the set of hypotheses and try to define the validity of the consequent of the implication. So please check. Now the moment you have added this A into the set of premises, you will be able to apply the rules. Immediately you will find out that, okay, oh, now I can apply the rule. So because this is A and this is A, therefore you can eventually perform the modus ponens on this too. So P implies Q and P will yield Q, that is B or C. Right? At the same time, you can also convert this into A implies negation of B. Right? So the moment you convert it into A implies negation of B, you can again apply modus ponens on this too. Now, A implies negation of B and A, therefore negation of B. Clear? Now let's look at this dilemma: B or C and negation of B. So this too will say, if B or C is true, and B is false, then for B or C to be true, C must be true. Now at this point of time, because C is true, and we already know, that C implies negation of D. So P implies Q and P, therefore therefore Q will hold true. So yes. Clear? So this is modus ponens, this is equivalence, this is also modus ponens, this dilemma, again modus ponens. You are able to say that whenever these four things are true, it is guaranteed that negation of D will also be true. So check whether the following argument is valid or not. So because we were able to prove this using the conditional proof rule, therefore it is a valid argument. Clear? What the idea? So these are the things which you need to understand. Now I am not discussing the PYQs of the propositional logic in the today's session. The logic is quite simple, that I don't want to do the spoon feeding. So I have explained all the concept of propositional logic. There is no other logic related to propositional logic, no logic related to propositional logic. So now you can eventually revise whatever we have discussed in this two particular session and try to solve the questions of PYQ. I'll have a separate session on the PYQs of mathematical logic, in which I'll include the questions of propositional logic as well as the questions of predicate logic. So we are done with the concept of propositional logic. From tomorrow we'll start the concept of predicate logic. From tomorrow 11 a.m. we'll start the concept of predicate logic. So in the very first session we are going to introduce the concept of predicate logic. We'll also try to understand the concept of relationship diagram, and this relationship diagram is very, very, very important in order to solve some questions. Clear? Because otherwise, if you don't know the concept of relationship diagram, then you may be able to solve the question, but you will waste a lot of time. So this is very important for time saving purpose, and also from the purpose of understanding the logic, that why certain things are being done. So that is what we will discuss in tomorrow's session at 11 a.m. Apart from that, tonight at 9 p.m. So yesterday
in this Prarambha series, I have already introduced the concept of bottom-up parser. I have already defined the concept of LR0 item augmented grammar. I also discussed that how to construct the DFA of LR0 item. Once we have constructed the DFA of LR0 item, now we'll convert, in today's session, we'll convert that particular DFA into the parsing tables, and based on the parsing tables we will check whether a given grammar is LR0 grammar or not, or SLR1 grammar or not. So the parser which is defined for the LR0 grammar is known as LR0 parser. The parser which is defined for SLR1 grammar is known as SLR1 parser. Right, so that's what we will discuss. And if the grammar is not LR0 grammar or not SLR1 grammar, then it will be because of the reason that there are some inadequate states in the DFA of LR0 item. So we will also understand that particular concept. So tonight in this Prarambha series, we are going to discuss three important things, and these are very important because the understanding of LALR1 and CLR1, that why do we actually need LR1 item, will be discussed in this particular session. That why do we have CLR1 parser, why do we have LALR1 parser. So the basic logic of derivation of those particular parsers will be in this particular session. So that will be all. So these are the two important sessions for you. Tomorrow at 11 a.m. we'll start the concept of predicate logic. Tonight at 9 p.m. we'll continue with the series of compiler design. Thank you very much. Thank you very much. If you guys have any doubt, then you can ask. Otherwise, I'll end the session. Okay, guys. Thank you.